Today we're going to learn about Robo Slit axonal navigation. It involves Netrin, DCC, and Robo with Slit attached. These are the characters you'll be seeing today, but they're just going to take a real quick break until we actually get down to it. Just remember, this is about the brain. Now here we see a growth cone. A growth cone is the axon as it's growing. It'll take on these shapes. These are called filopodia up here. It's being pushed forwards with the microtubules, and the filopodia are actually filled with actin, and the actin grows in the direction of which the axon is repulsed or attracted. The midline for the slit-netrin gradient is found up here at the top. This tells us where the highest concentration of slit and netrin are, which are both ligands for the Robo and DCC complexes. DCC is a receptor found on these filopodia that, when netrin interacts with it, will actually be causing an increase of actin to be developed inside of the area around this filopodia. So this makes so that the particular filopodia that are in the highest concentration locations are going to be grown further and farther, and filopodia that are found in low concentration areas will actually have their actin be reduced. But warning, this next section, nobody really understands how it works. So here we see the midline, the axon has finally passed it, and in the center we have our Robo and our commissuralis. Now the issue is that we don't really know if commissuralis is holding Robo inside the growth cone in a separate membrane, or if it's somehow downregulating the expression on the actual axonal membrane. Since we don't know, it's been depicted in a couple different ways. One is this, as you see here, where commissuralis is actually holding Robo within the axon, and once the growth cone has passed the midline, Robo is then able to be brought to the membrane of the outside of the cell. Or, conversely, it could be that it's downregulated somehow, and it just is not being as expressed as DCC is on the outside. Now, what's important about Robo is that it actually causes the DCC to be cleaved. And when that happens, when Robo has been attached with, Slit has attached to Robo, and the DCC is clipped and become DCC stubs, then there is a repulsion force from the gradient, which the highest level of Slit is now below where we are currently viewing. And since there's a lower amount of Slit further away, the more Robo you have, the further you'll get. What do I mean by that? Well, there's actually a couple different kinds of Robo. Robo 1, 2, and 3 were discovered in that order. However, Robo 3 is a little different than Robo 1 and 2. We won't go exactly into detail on that today, but all you really need to know is that if something contains only Robo 1, it's most likely not going to get very far from the midline. If it contains 1 and 3, it can get a little further, and if it contains 1, 2, and 3, it will go the furthest. Now, if something contains all of these, it will go far. However, it could be found in Robo 1's area. It could be found very close to the midline. This depends on a number of factors that are a little more complex than we're going to get into today. Now, if you see here, we have this bluish gradient with it being darker on the left side and lighter on the white side. This is kind of just to represent what comes next that you don't necessarily need to know for Robo Slit axonal navigation. However, there will be other gradients of other kinds of chemicals that are involved in the extracellular matrix that will actually determine where the final end of this neuron will be. Thanks for watching.